So let me quickly explain what I did here. So based on your question, step 1 is to formulate the above problem into linear programming, blah blah blah. So maximize x. So where you have your profit, that profit, you will notice that you have product 1 to be 7 and product 2 to be 9. So you have to maximize it. So maximize z. Sorry, that z value is what you have to maximize or minimize. So because it's profit, we need to maximize that. Is how to increase the profit. So you put it into a linear programming model like 7x plus 9y. Remember I said let x represent product 1 and let y represent product 2. So 7x plus 9y subject to. So what are the constraints? The constraints are raw materials and your labor. So in that table, you'll notice that your products for the raw materials, product A, product 1 is 6, product B is 7, and the other side of it is 42. So in case you are asking the theory aspect, this 42 is the right hand side value. This 42 is the right hand side value. Why this x and y are the decision variable? That is, they are the constant that you should solve for. It's in the theory aspect. So this is for the raw material and this is for the labor. So we're given the demand for product A and product 1 and 2. So we have that x is less than or equals to 5, y is less than or equals to 4, which is the demand constraint. It's in the table. So you should notice that when you are dealing with maximization, you are going to for maximization you are going to use inequality of less than or equals to. So you maximize profit, and if they are silent about it, and if you are dealing with profit or contribution, just know that you are maximized, because as a business you need to increase your profit. Then for minimization comes into play when you are dealing with cost. Like at times you might be given profit in that table or cost. If it is cost, it's going to be minimized. That's how to reduce the cost. So if it is the minimization aspect, you are going to use your less than or equals to. So I will show you how this inequality will come into play when you are drawing your graph. So you write out the inequalities like this, like so. Then step 2, you convert the above inequalities to a normal equation like this that I have here. Then x is 5, y is 4, which is this demand constraint. Then for these constraints, for the raw materials, now you have to substitute, like if x for this constraint 1, which is this raw material here, you have to find a way that if x is 0, what is y? And if y is 0, what is x? Which is what I did. If x is 0, y is what? 6. If y is 0, x is what? 7. So I wrote it out somewhere. If x is 0, y is 6. And if x is this, y is... That is exactly what I did here. The constraint 2, which is the label, the same thing too. If x is 0, y is 5. If y is 0, x is what? 10. So I wrote it in a table like this. So you now plot your graph. You plot your graph. So before I plot the graph, I know how to plot graph. You know the highest and the lowest value. So we have the lowest value is 5. Your highest value is 10. So it means that in your graph, 5 and 10 has to be inclusive. So when x is 0, y is 6. When x is 0, my y is 6. This is it. Then the other one says that when x is 6, y is 0. When your x is 6, your y is 0. So use your ruler to connect to connect from here to here. So this is the first constraint, 6x plus 4 7y equals to 42, which is this one, this one, this one is for this one. Then you do the same thing here, which is you connect it again. Then this demand, or for x, which is 5, just go to x-axis. This is 5, your x-axis. This is 5, just use a ruler to roll it up. And your demand for y is 4. Why is this time blue? So your demand for x is 4. You use a ruler to roll it as well, like this. You can see y is 4, x is 5. So then your visible, so you have to check your visible region before you can get your corners. So like I said, this is maximization of profit. Like I said, if they are quiet about the maximization or minimization, you will know. If it is profit, it is maximization, and if it is cost, it is minimization or labor time. So because this is less than or equals to, so we are going to shade. So watch out, this place is like a boundary, this and this. So I'm going to shade downward like this. So here is the boundary. This my x, this my y, then this one that I plotted. Just shade the lower part. Don't shade there, just shade the lower part, the lines below. That's what you need. This one too is inclusive, like this. Yeah. So then you can now find your corners. Your corners is within where you shaded. So A, B, C, and D. So my A, for your A now, your x is 0 and your y is 0. For B, your x is 5 and your y is 0. X is 5, y is 0, which is here. For your C, your x is 5, y is 4, 5, 4, which is this. And your D, which is this, your x is 0, 0, y is 4, so 0, 4, which is this here. So using this profit model that is given the question between 9x plus 7x plus 9y, which is this thing that we're trying to maximize. You now create a table like this, all your corners A, B, C, D, X, Y. So when X is 0, 0, 0 for B, 5, 0 for C, 5, 4, and for D, 0, 4, which is what I have here. So you start up. So you now use your this profits model. You start substituting the X and Y. So your answer, you have something like this here. So the highest contribution here is 71 naira. So it is at corner C that you will maximize